Welcome everybody to Algebra 2, Section 1.2, Solving Equations and Multi-Step Word Problems. So for solving equations, we have some basic steps to follow. This is kind of a general guideline, so a good first step is to distribute if you need to. Then to simplify each side by combining like terms. Move variables from one side, or move variables all to one side, and move the numbers to the other. And then solve using inverse operations such as subtracting to undo addition or dividing to undo multiplication. So number 1 here, 6 times the quantity of n plus 5 equals negative 18. So to solve this one, a good first step would be to distribute the 6, and to get 6n plus 30 equals negative 18. So the variables are already on one side, we only have the one n, and now we need to move the number to the other, because remember our end goal is to have numbers on one side, variables on the other, something like that. So I'm going to move this 30, and how I get rid of a positive 30 is by subtracting 30, and if I do it to one side, I must do it to the other. So I have 6n equals negative 48. Now I divide to undo multiplication, because currently my n is being multiplied by 6. I want to undo that by dividing it by 6. And because I divide one side, I must divide the other side, and I have n equals negative 8 as my answer. You can always check your answer by plugging it back in and saying negative 8 up here, adding it to 5, multiplying it by 6, and double checking you get negative 18, which you would. I also want to note there's an additional way to solve this problem that some of us might end up preferring, where you would do, instead of distributing, since 6 is multiplying with n plus 5, you can actually undo that multiplication by dividing. And if you divide this by 6, you end up getting n plus 5. However, you'd need to divide the other side by 6. So when this can be handy is if what's outside the parenthesis here that you would distribute in normally can divide into the other side. So because negative 18 can divide by 6, you end up just getting negative 3. And that will save us a step later, as well as making our numbers smaller. So now if we subtract 5, we end up getting to our last step right away and getting n equals negative 8. So look for that when you notice that the other side of the equation can be divided by what's outside the parentheses. Number 2, 3 times the quantity of 5 minus 3x over negative 4 equals negative 14 or negative 15. So we have to undo this division of negative 4 before we go any further. How we would undo that division is by multiplying by negative 4, or negative 4 over 1 if you prefer, and doing that to both sides. So if I multiply both sides by negative 4 or negative 4 over 1, we end up having those negative 4's reduce, and so we end up getting 3 times the quantity of 5 minus 3x is equal to positive 60. So like I talked about earlier, you could just divide both sides by 3 at this point, or you can distribute that 3. Since I noticed that, hey, 60 is divisible by 3, I'm going to go ahead and divide by 3. Those 3's reduce to 1. And now I get 5 minus 3x equals 20. That gets my numbers smaller, and it saves me a step later. So now as I subtract by 5, I get negative 3x is equal to 15. So now I have my variables on one side, my numbers on the other, so now is the time for me to divide to undo that multiplication by dividing by negative 3. And I get x equals negative 5. I also want to note another way you could have started this problem. We could actually, instead of multiplying by negative 4 and dividing by 3 in 2 separate steps, do that in the same step. Multiply by negative 4 over 3. And what would happen is negative 4 reduces with negative 4, 3 reduces with 3, and on the left side we're left with 5 minus 3x, just like we ended up getting later anyway. And on the right side, we end up having negative 4 over 3, we'd put the negative 15 over 1, and we reduce negative 15 with 3. And they reduce by 3 to become negative 5 and 1. And so now as we multiply negative 5 times negative 4 straight across, we end up getting those to equal positive 20 over 1, or just positive 20. And we notice that's identical to what we got here. and so the problem would continue on just the same. Next up, number 3, before we can potentially divide that, we'd first want to add 5 to move to the other side. If you wanted, you could distribute and add 5 in the same step. So I'm going to go ahead and just leave that, or I'm going to go ahead and distribute the 2 in the same step this time, just because I'm going to prefer to go ahead and take care of it now and deal with the bigger numbers. And the reason I preferred that in this scenario personally, and that's just a personal preference here, is because I didn't want to take the next step to divide, and so I'm actually speeding my process up a little bit because this isn't a 1y anyway, so I'm going to have to divide at the end of the problem regardless to get my y by itself. But if I had wanted to, I could have kept this as 2 times the quantity of 2 minus 7y, and in this step divided by 2. That'd be perfectly fine as well if I preferred smaller numbers rather than one less step to write. So I'm going to subtract 4 to get it away from my variable and toward the other numbers. Remember, the goal is to get variables on one side, numbers on the other. So we have negative 14y equals negative 28. Divide by negative 14, and I end up getting y to equal positive 2. Next up is number 4, fractions, exciting stuff. So left side is going to be negative 16. The right side we're going to distribute negative 15 over 16 to both terms. Now I'm going to go ahead and do my math off to the side here. Negative 15 over 16 times 4 over 5q. Cross reducing, I can reduce 5 and 15 by 5 to become negative 3 and positive 1. 16 and 4 cross reduce as well by 4 to become 4 and 1. And so now as I multiply straight across, I end up getting negative 3 over 4, and that q is still there. So now as I go ahead and distribute 15 over 16 to 32 over 3, once again I'm going to go and do this work off to the side and get negative 15 over 16 times 32 over 3. I can reduce 15 and 3 by 3 to become negative 5 and 1. And 16 and 32, 16 goes into both. Goes into 16 once and 32 twice. So now multiplying straight across gets me negative 10 over 1, or just negative 10. Writing this work off to the side can do a lot to help our problem stay cleaner and more organized here, and make the fraction seem a little bit less intimidating. So now I'm going to add 10 to undo the addition and move my numbers to one side while my variables are already on the other, and get 26 equals negative 3/4 times q. And anytime you have a fraction in front of a variable, or a fraction multiplying with a variable, to undo that, you'll multiply by the reciprocal. Typically, we'd look to divide, but if we divide by this, that creates a double-decker fraction, as I like to call it, or multiple fractions in a row. And that gets really messy really fast. And so it's the same thing to divide a fraction as it is to multiply by its reciprocal. Reciprocal just being the flipped version. So if I multiply instead by 4 over negative 3 on both sides, we'll accomplish the same result as dividing the fraction. So these negative 3's reduce, the 4's reduce, and we end up with q just like we were wanting to. If you don't end up with just your variable in the step, you're doing something incorrect. So I'm going to put 26 over 1 and look to cross reduce. 3 and 26. Oh, my apologies there. That should not be 26. I made a mistake earlier that I'm going to fix. The mistake I made earlier, let me point it out to everybody, is negative 16 plus 10. I called that 26. However, that would be negative 6. If you caught that earlier, you're probably confused by what I was doing here, and I apologize for that confusion. I realized I made a mistake when I knew that these weren't going to reduce, but I knew they should have. So, and the reason I knew they should have, I should say, is because I've worked through this problem before. So negative 3 and negative 6 reduce by 3 and become positive 1 and positive 2. And now we multiply straight across and get 4 times 2 equals 8. Next up, number 5. We have variables on both sides this time. So my goal is to get the variables on one side and the numbers on the other. So ideally, I keep things positive. That makes my life a little bit easier. So I'm going to try and move the smaller variable toward the bigger variable. So 6a is smaller, or negative 6a is smaller than positive 10a. A negative is always smaller than a positive. So I'm going to move that one from right to left by adding 6a. If I add 6a to one side, I add it to the other, and I get 16a. Now, oftentimes, I'll actually do this next step at the same time I did the last step. I'll show that in a moment. So now I'm going to add 7 to both sides to move my numbers to the other side of the variables. So 16a equals 28. Now as we tried to divide by 16, we notice 16 doesn't go into 28, and that's okay, we'll just reduce. 4 goes into both numbers, and it becomes 7 over 4. So oftentimes on that previous step, on that previous part of the problem here, I would do this. Where I add 6a to both sides and get 16a. And at the same time, I'm also adding 7. And having two different colors here makes this a little bit easier to keep straight. But you can do it with pencil or pen as well. And so now the rest of this problem ends up just the same as it did here. But by doing both steps at the same time, it saves me some writing. On number 6, we got more of these lovely fractions. Currently, this left side is just going to wait and stay the same, where the right side we have to distribute this negative 1/3. If you wanted to, you can multiply both sides by negative 3 over 1, the reciprocal. It'd be the same thing as dividing by negative 1/3. So that would be an option as well if you would like, kind of like we did on the first couple problems. So instead I'm just going to go ahead and distribute this though, and negative 1/3 times 2, or negative 1/3 times 2w is going to be negative 2/3 w. If you want to write that off to the side, feel free. And negative 1/3 times negative 9, I will write off to the side as I reduce this one. I put the negative 9 over 1, look to reduce. 3 goes into 3 once, it goes into negative 9, negative 3 times, and negative 1 times negative 3 ends up getting us positive 3. Now I need to move my variables from one side to the other, and so I'm trying to move my smaller variable toward my bigger variable. The negative is smaller than the positive, so I'm going to move that one. However, before I add it to the other one and combine it, I'll need to get common denominators. My common denominator is going to be 6. So I'm going to multiply the top and bottom here by 2 to make 3, 6. So I get 5 over 6w plus 21 equals negative 4 over 6w plus 3. Now it's much more doable for me to add 4 over 6w to 5 over 6w since they have common denominators and get 9 over 6w, which we'll reduce in a moment. But before we do that, I'm going to go ahead and subtract 21 from both sides to move my numbers to the other side and get negative 18. Reducing 9 over 6 makes it 3 over 2. Now that that is reduced, I'm going to go ahead and multiply by the reciprocal to get w by itself. So I'll multiply by 2/3. So 2 and 2 reduce, 3 and 3 reduce, and I get w, which was the goal. On the right-hand side, 3 and 18 reduce to negative 6 and 1. Multiplying straight across gets us negative 12. On number 7, so I could either distribute negative 5 right away, or I can divide by negative 5 right away. If I divide by negative 5 right away, however, since there's multiple terms here, I have to remember that I'm dividing every single term by negative 5. And on this problem, both 5 and negative 5 divide by negative 5 quite well. So I'm actually going to go ahead and take advantage of this opportunity to do that. And so those reduce to 1, and we get 8p plus 6 equals negative 1 plus p as we reduce these 5's. And a negative divided by a negative is a positive 1p. Now, if you didn't do that, you would still be able to solve this problem just fine. You would just start by distributing instead. And so you would end up having negative 40p minus 30 equals 5 minus 5p. And I'll showcase how to solve each of these. So on the left here, this one, I'm going to move my smaller p toward my bigger b by subtracting p and get 7p. I'm also going to go ahead and subtract 6 to move my numbers to the other side and get negative 7. On the problem here on the right, I'm going to move my smaller p toward my bigger p. My smaller p is negative 40, so I'm going to add 40p. You also could move negative 5p to the other side. I just prefer to try and keep the p's positive. I wrote that prematurely, my apologies. So on the right side, we'll end up having 35p. I'll also subtract 5 to go ahead and move that number to the opposite side and get negative 35. At this point, both problems are quite similar to where you divide by whatever variable or whatever coefficient of p that we have. So we get p equals negative 1, or in the other one we divide by 35, and we still get p equals negative 1. So these problems both required the same amount of steps, whether we distributed first or whether we divided by negative 5 first. The one on the left kept it smaller, but it did require me to divide everything by negative 5 early, and remember to divide everything rather than just divide one or the other. At the end of the day, it is a preference. 8. So our first step here would be to distribute this negative. So we can't. We could divide by something there, but it wouldn't really work the best because we're adding 16 with it first. So I'm going to distribute that negative by changing it to a plus sign and making every sign in the following parentheses the opposite: negative 7m and negative 3. On the right side, we can distribute this 8 and get 8 minus 8m. On the left side, now that I went ahead and took care of those signs, I can combine 16 and a negative 3 to get 13. So I have negative m plus 13. If you wrote 13 minus 7m, that is also fine. The order of those are not concerning to us right now. So my smaller m is negative 8m. Negative 8 is smaller than negative 7 because it's more negative. So I get positive 1m, or just m. On the other side, I subtract 13, and I get negative 5. Moving on to the next page, we have more equations. And we start out with this whole left side of the equation being divided by 2. And so before we do too much, we have to undo that division by multiplying. So we'll multiply by 2, or 2 over 1. And we'll multiply the other side by 2, making sure to multiply that entire right side, not just one part or the other. So the left side is 10x plus 17. I'm going to go ahead and take care of this negative while I'm here as well, to change the signs inside the parentheses to the opposite. And I'm going to distribute this 2 to get 6x plus 2. I think I wrote that parenthesis accidentally there. Now at this point, I can combine like terms on my left side. I get 10x minus x is 9x. 17 plus 9 is 26. And the right side is just staying the same. Now I'm going to move my smaller x by subtracting it and get 3x. I'm also going to take care of the 26 by subtracting it to move to the other side and get negative 24. Dividing by 3 results in x equaling negative 8. Number 10. We have to distribute 9/8 to this left-hand side of the equation. So I'm going to go ahead and take care of that, and I'm going to do my work off to the side. So I'm going to write 9 over 8 times 4 and put the 4 over 1. Looking to cross reduce, 8 and 4 reduce to 2 and 1 respectively. And so we multiply straight across and get 9 over 2. So that is 9 over 2 in that space. I also have to do 9 over 8 times a negative 1/2 a. Reducing 9 and 2 can't happen because nothing goes into 9 and 2, and only 1 goes into 8 and 1, which doesn't make it smaller. So we just multiply straight across instead and get 9 over 16a. On the right hand side, we distribute this 3. Multiply just straight across here. 3 times 1 is 3. This is secretly over 1, so it becomes over 4 still, because 1 times 4. If you want to do that off to the side, feel free. And 3 also doesn't reduce with 2, which is why I'm not bothering doing it off to the side, and just getting 15 over 2. Remembering top times top and bottom times bottom. Now we have to move the smaller of the a's. Since one of them is negative, it becomes obvious that this one's smaller than the positive version. So I'm going to add that number to the other side. However, I need common denominators. My common denominator will be 16, so I'll multiply this fraction by 4 on both the top and the bottom. So I'm going to get 9 over 2 minus 9 over 16a equals 12 over 16a plus 15 over 2. I do want to note that I will also need to be moving these constants together, the halves, but because they already have the same denominator, I'm not bothering to change the denominator in this step because I don't need to. So now as I add 9 over 16 to both sides, or 9 over 16's a, I should say, I end up getting 21 over 16a. The right-hand side, as I subtract 15 over 2, I end up getting negative 6 over 2. Thankfully, I know negative 16 over 2 is just negative 3. So as I have negative 3 equaling 21 over 16a, I look at that and say, oh, I need to undo that multiplication of 21 over 16 by multiplying by the reciprocal, which is the same as dividing. I'm going to put negative 3 over 1 and look to reduce. 21 and 3 reduce to 1, or 7, I should say, and negative 3. Try that again, negative 1. And so now, moving my answer over here, so I have some room, 16 times negative 1 is negative 16. On the bottom, we have 7. On the right-hand side of the equal sign, 21 and 21 reduce to 1, 16 and 16 reduce to 1, and so we get negative 16 over 7 equals a. Now it's time for some special cases. So on number 11, we would first start by distributing this 5. There are other ways you could start that aren't necessarily incorrect, but that's just the way I would start first, my personal preference. 1 plus 3c is equal to 5 minus 5c plus 8c. Now I'm going to go ahead and combine these c's and get 1 plus 3c is equal to 5 plus 3c. If you were to start moving your c's together, you would say, wait, which one's smaller? Well, they're the same. So if we subtract 3c from one side to the other, either way, you end up with 0 c's left. A common mistake I see here is people are still writing c. However, that means there's a 1c, and that's not correct. There's 0 c's, and 0 times any number is always 0. So we just have 0 here. And so I would end up having 1 plus 0 equals 5, which 1 plus 0 is just 0. So we end up with 1 equals 5, which is an incorrect statement. 1 does not equal 5. So we say there is no solution, which you can abbreviate to just no SOL. And I don't care which way you write it, whether you write out solution or you abbreviate it. If in this last step you would handle that slightly differently, I will show it on the right hand side here, by not only subtracting 3c, but also subtracting 1 or 5 from both sides either way, you'd end up with 0 equals 4. Now that is equally incorrect as 1 equals 5. And so regardless, you end up with no solution. Anytime you get an equation that is false, there's no variables, and it is untrue, it is no solution. That means no matter what number you plug in for C, it will never work. You could sit there trying all day long, all week long, all month long, whatever, trying different numbers, and none of them would ever be successful. Number 12 here, we could either divide everything by -8 or distribute the -8. It doesn't truly matter. To keep up with the theme from earlier, maybe I'll just divide by -8. And I get -5 plus x equals x minus 5. I'll go through this problem if you didn't do that as well, if you just distributed instead. So now if I subtract x from both sides, I notice I get 0. And I get -5 equals -5. We have no variables again, however, this is a true statement. -5 is in fact equal to itself. So this time you get IMS, which is abbreviated for infinitely many solutions. Which means no matter what you plug in for x, it will work every time. You can plug in any number you think of and it'll always work. It is also known as sometimes all real numbers. Just meaning any real number would work. Whether you see IMS or infinitely many solutions or all real numbers or AR number sign for all real numbers to abbreviate it, it is the same exact thing. So if I were to have started off on this problem and distributed instead, I'll showcase what would happen. So 40 minus 8x is equal to -8x plus 40. And so if we add 8x, you still end up with 40 equals 40, which is a true statement. If you had subtracted 40 from both sides, or subtracted 5 from both sides in the previous step, the same thing would happen. Or in the previous example, you'd get 0 equals 0, which once again is a true statement. 0 does equal 0. Let's work on proportions here on number 13. So a proportion is when two fractions are being compared. Or for math, we're concerned with two fractions equaling each other. Whenever you have this, a good rule of thumb is to cross multiply. That means you multiply the diagonals together. So 5 would multiply with x plus 4, and 2 would multiply with 40. So as we do 5 times x plus 4, it's important that you put parentheses around x plus 4, because there are multiple terms. If there are multiple terms with 5, if it was 5 plus x, you'd want parentheses around that too and squish that in there. So now as we multiply this, 5 times x is 5x, 5 times 4 is 20, 2 times 4 is 80. Now, a lot of people don't even write this pink step. As a matter of fact, I typically don't write that pink step. I would just end up jumping right to the blue and multiplying 5 to both of these. However, writing this pink step might help you if you are a person that might forget to multiply 5 to everything in that other denominator. So now at this point, I'm going to subtract 20 from both sides and get 5x equals 60. Also, I'm going to stop writing the addition and subtraction on every single step and imply it instead and just speak it instead of writing it every time. Dividing by 5 on both sides gives us x equals 12, and there I just didn't write the division either, because we can assume at this point what happened between the steps. And if you ever have a question on that during class, you can always ask me as well. Number 14, because again we have two fractions equal to each other, a proportion will multiply diagonally, or cross multiply. So 10 times 2x minus 8 would be 20x minus 80. 8 times 5x minus 9 would be 40x minus 72. Notice we distributed 8 to the 5x minus 9 and 10 to 2x minus 8. Now as I subtract 20x on both sides, I get 20x on the right-hand side. If I add 72 to both sides, I get negative 8. Dividing both sides here by negative 20, I'm actually going to write out this time, and the reason I'm writing out is it's not nearly as straightforward as it was on this problem, because 5 went into 60, but here 20 does not go into 8, so we're going to have to reduce this fraction. This fraction would reduce by 4 and become negative 2 over 5. Now we're talking about literal equations. Literal equations are equations that you solve for a variable. Rather, I should clarify that we always solve equations for a variable. They're equations that when you solve for a variable contain other variables you didn't solve for. So the problems don't seem quite as finished when you see the answers as the problems we've solved earlier. So here we're supposed to solve each equation or formula for the specified variable. So on number 15, our formula or equation is c equals 2 pi r, which happens to be the circumference of a circle. And we're supposed to solve it for pi, meaning our goal is to get pi by itself. Now what's interesting here is that actually pi isn't a variable, but that's okay. I'm not going to be too concerned about that right now. Regardless, our process is the same. So if we're solving for pi, we ask ourselves what's happening to pi, just like when we solve other equations. And pi is being multiplied by 2r. So how we undo multiplication is by dividing. So we divide by 2r. 2 divided by 2 is 1. R divided by r is 1. And we're left with pi. However, because we divided one side, we have to divide the other side by the same thing, 2r. Now, typically when we divide, we can at the very least reduce, like we did on the previous problem, reducing 8 and 20 to 2 and 5. But here we can't reduce c with r or c with 2, and so we actually just have to leave it as c over 2r. If we knew a value for c or knew a value for r, we'd be able to do more on this problem, but because we don't, we end here. So pi is by itself, it's all the math we could do on the other side, so we're done. Number 16, a equals 1/2 a times p. We're solving for p. So p is being multiplied by 1/2 a. Well, we're actually going to have to split this up into 2 steps. That's interesting. Somehow my problem started wanting to put a hyperlink in there. Not quite sure where to. But ignoring that, we need to get rid of the 1/2 as well as the a. Undoing the 1/2 is not as simple as dividing 1/2, because remember that creates that double-decker fraction. So instead we multiply by the reciprocal, 2 or 2 over 1 to both sides. So those 2's reduce, and then we get 2a equals a times p. Notice this a on the left is capitalized and the a on the right is lowercase. So we need to treat them as separate variables from each other. One is talking about the area, and one is talking about the length of the apothem, which is an aspect of some polygons. So now getting the p by itself would be done by dividing by a. And so we get 2 times capital A over lowercase a equals p, and that would be our answer. If you wanted, you could have done those 2 steps in the opposite order, and it would have been okay. If you would have divided by a first and then multiplied by 2, you'd get the same exact result. Number 17, if we're solving this equation for b, we have to say, okay, do we undo the a plus b or the c first? And the answer is you have to undo c first, because a is being divided by b, or c, just like b is being divided by c. Now, if it were this instead, a plus b over c equals 5, well, I wrote 6 instead of c, then you could move the a before getting rid of the c. It wouldn't be encouraged even. But as it sits, because the entire part is being divided, we're best off multiplying by c or c over 1 and letting those c's reduce. And so we get a plus b equals 5 times c. On the other side, or now in the next step I should say, we have to get rid of the a by subtracting it. So we end up getting b equals 5c minus a. Number 18, 3x minus 3y equals 24, and we're supposed to solve for x. So x is currently being multiplied and subtracted. So we have to undo both of those things. We want to undo the subtraction first. If you wanted to undo the multiplication, you could, but remember you have to divide everything by 3, which isn't a bad scenario on this problem since everything is in fact divisible by 3. However, I'm going to go ahead and add 3y to stick with our usual method. And get 3x equals 3y plus 24. If you put 24 first and 3y second, that's fine. However, you can't combine them and call it 27 because they are not like terms. One has a y and the other one does not have any variables. So our next step now would be dividing it by 3, and we'd want to divide absolutely everything by 3, giving us x equals y plus 8. Next up on number 19, we are supposed to be solving this for v. So I could start by distributing the 1/2, and if I do, I would still be able to get the right answer, but it's going to make my life a little bit harder along the way. So I'm best off multiplying by 2 over 1 to undo that right away, and multiply the other side by 2, and now I don't have a single fraction to deal with. My life became a lot easier there. I can showcase how to solve that problem for v if you were to have distributed that as well. So now as I subtract w from both sides, I can actually just combine that with 14w and get 13w equals v. So my v is by itself. I can't do any more math on the other side. I am done. So if you had distributed this 1/2, we would have 7w equals 1/2 w plus 1/2 v. And so as we subtract this 1/2 w, we'd actually have to get common denominators by multiplying the other fraction by 2 and getting 14w over 2 equals 1/2 w plus 1/2 v. And so as I subtract 1/2 w, I end up getting 13 over 2w, subtracting the numerators while retaining the denominators or keeping them the same. So now I have to do the same, multiplying by the reciprocal regardless to undo the 1/2. And so 2's reduce and we get w, and the 2's reduce and you get 13 w. Or my apologies there, I wrote w on this right hand side, but this should be v. Because it's this 1/2 v here. Sorry, this one should be w because we subtracted 1/2 w, but this should be v there. That's the one I miswrote. And so in the answer, that should be v as well. And we notice that's the exact same answer we got the other way, just with more work. Number 20, s equals n minus 2 times 180. Same thing, I could distribute and then deal with these bigger numbers and divide again, or I'm just going to divide by 180 right away and get s over 180 is equal to n minus 2. Now I have to add 2, and I do not have to get common denominators because these are not like terms. One has an s, the other does not. So I get s over 180 plus 2 equals n. And that plus 2 is not part of the fraction. All right, let's continue on. So now we're going to talk about using equations. So on these problems, we're going to be setting up and solving an equation for each of them. So we're having to translate the words into math, verbal expressions into, or verbal equations into algebraic equations. So the product of 7 and a number. Here's a hint. Anytime you see a number, it's telling you it's a variable, and you can pick whatever variable you so please. So the product of 7 and a number, so 7 times x, ignore that notification, increased by 3. Increased by means adding, so adding 3 is equal to, that should be a big radar going off or alarm going off telling us, hey, that's where our equal sign is. Twice the number. So it's saying the number, meaning the number we used previously, or x. So 2 times x. Or if you had used n, it'd be 2n. My apologies. It says subtracted from 39. Twice the number subtracted from 39. I had missed this last part for a moment there. Meaning we do 39 minus 2x. Whenever we see the phrase subtracted from or less than, that actually means we have to reverse the order. Typically we just go left to right as we see it. So we'd put twice the number first, or 2x first. But because we see subtracted from or less than, we have to flip it around and put the second part first. So 39 minus 2x, or subtracting 2x from 39. Now that we have our equation, we're going to solve it the exact same way we'd been solving it. So I'm going to add 2x to both sides and get 9x. I'm going to subtract 3 from both sides and get 36. And I'm going to divide both sides by 9 to get x equals 4. So the new part of this is setting up the equations. Number 2, 5 less than, there's another phrase like subtracted from again, where we're going to have to turn it around. 5 less than twice a number is equal to, that's our equal sign. So twice a number, I'm going to do 2x again, minus 5, because we're doing 5 less than 2x. So we switch the order. Half the difference of 3 times the number and 13. So half is 1/2. Difference means subtraction. So 1/2 times subtraction, meaning difference is the result of subtraction, so we have to subtract first. So how we know subtraction would come before multiplication, because when you're doing half, you're multiplying by 1/2 or dividing by 2. You have to put it in parentheses to tell us this subtraction is coming first. 3 times the number, the same one we used, and 13. So we're doing 3 times the number minus 13. So whenever we see difference of, or sum of, or product of, or quotient of, those results-based words, we have to look for the word and. When we see the word and, that's where our sign's going. So we're doing and is that minus sign. Now we have our equation. So I could either distribute this 1/2, or I can multiply both sides by 2. And I'm going to prefer to not deal with variables, or not deal with fractions by distributing 1/2, and instead multiply by 2 over 1 to the entirety of both sides. So 2 and 2 reduce, and on the right side we get 3x minus 13. On the right side I have to make sure I distribute my 2 to both terms, and getting 4x minus 10. This makes my numbers a little bit bigger, but it keeps them from being fractions, which I'm going to prefer. Now I subtract 3x from both sides and get x. I add 10 to both sides and get negative 3. And I have my answer. Number 3, one number is 9 more than twice another number. If the sum of the numbers is 129, find both numbers. So, one number is 9 more than twice another number. So we're going to call one number x, and the other number is what we're talking about here. One number is 9 more than twice another number. So here's the another number, and the one number it's talking about is 9 more than twice the other one. So 9 plus 2x. So if one of your numbers is x, this other one is 9 more than 2 times that. And it's important to note that off to the side that one of them is one number and the other is the other number. So maybe we call this the first number, and the second number. And which one you call first or second doesn't really matter here. Now, we're told if the sum of those numbers is 129, so we're adding them together. So x plus 9 plus 2x. And you can put that in parentheses if you want, but it doesn't matter here because we're adding. If we were subtracting, it would matter because we'd have to change the signs. The sum is, the adding is 129. We're supposed to find these numbers. So this is a unique problem to set up. We have to take note that we have multiple sentences here. See 2 different periods there, multiple sentences here compared to previous problems where we have not had multiple sentences for our prompts other than just saying find the number was the only part of the second sentence. We're here, if the sum of the numbers is 129 is another part of that sentence. So it's part of a separate sentence. And so we have to know that we are going to be saying what we're dealing with in one spot and then actually dealing with it in the other spot, or plugging it in the other spot. Now as we start solving this, if we combine x plus 2x, we get 3x. Subtracting 9 from both sides gets us 3x equals 120. And dividing by 3 on both sides, x is 40. So that's one of the numbers. We were asked to find both numbers. So we found this one is 40. Now we have to find the other one by doing 9 plus 2 times 40. So that'd be 9 plus 80, which results in 89. So our two numbers, must have not written that 0 there, are 40 and 89. If you had wanted to, you could also have found that second number, 89, by saying 40 plus x, or 40 plus some other number, y, for example, is equal to 129, because we know the sum of the numbers is 129. And saying moving on to number 4, Kara's golf score was 1 less than 3/4 of Greg's golf score. So we're going to say, so since Kara's golf score is based upon Greg's golf score, we're going to solve Greg's golf score, x, where Kara's is going to be the modified version. Kara's score was 1 less than 3/4 of Greg's. So 3/4 of means 3/4 times, of means times, so 3/4 x, and it's 1 less than that, so we subtract it by 1. Now we're told if the sum of their scores is 153, find Kara's. So now we add Greg's and Kara's together. Once again, this is part of another sentence. That's a big hint that we're going to have to set up the problem this way rather than how we did in 1 and 2. So x plus 3/4 x minus 1 equals 153. So I'm going to get common denominators to combine these. 1x over 1 is secretly 4 over 4 if we multiply by 4. And so I'll get 7/4 x minus 1 equals 153. Adding 1 to both sides gives me 7/4 x equals 154. And now I'll multiply by 4 over 7 on both sides. And 7 goes into 154 exactly 22 times. And if we do 22 times 4, we get 88. So Greg's score was 88, and we have to figure out now Kara's score. You can either plug it back in and deal with fractions, or, like I was talking about at the end of number 3, we can say, hey, we know they add up to 153. So 153, subtract 88 from it, and that'll give you Kara's score. And so that tells us, hey, Kara's score is 65. We were supposed to find just Kara's score, so 65 is our answer. If you were to happen to list both 65 and 88, you just want to be careful that you read the instruction on that one, but knowing that you found both, I wouldn't be upset about that and wouldn't count it wrong. The length of a rectangle is 1 more than 4 times its width. The perimeter of the rectangle is 62 meters. Find the dimensions of the rectangle. So here we're dealing with two different numbers again that we're trying to find both of them. And notice this is part of a separate sentence again. So length is 1 more than 4 times its width. So our width is just going to be x. The length is 1 more than 4 times that. So 4x plus 1. Perimeter. Perimeter is adding up all sides of the rectangle. So a rectangle has 2 lengths and 2 widths. So we have to do 2 of x as well as 2 4x plus 1. So we have to double each of them. And if we add all of that up, we get 62 meters. So you can either write x plus x, or just write 2x, and you could write 4x plus 1 plus 4x plus 1, or do what I did and write 2 times that. And so now as we distribute, we get 2x plus 8x plus 2 equals 62. Conversely, you could actually divide everything by 2 here as well instead of distributing, since all of these are divisible by 2. Now if I combine like terms, I get 10x plus 2 equals 62. Subtracting 2 on both sides gives me 10x equals 60. And dividing by 10 gives me x equals 6. Now I'm supposed to find both dimensions, so I need to plug it in to find the other one. If I plug this in to find my other dimension, I get 4 times 6 plus 1. 4 times 6 is 24, and 24 plus 1 is 25. So one side is 6 meters long, and the other one is 25 meters long. We knew the unit because it was used right here. If you just say 6 and 25, rather than say 6 meters and 25 meters, you will lose a half point, so be careful on that. 6. The length of one base of a trapezoid is 19 less than 5 times the length of the other base. If the trapezoid has a height of 18 feet and an area of 477 square feet, find the length of the longer base. So it's important for us to note here the formula for area of a trapezoid. Area of a trapezoid is 1/2 times base 1 plus base 2 times the height. So once again, 1/2 times base 1 plus base 2 times the height. Important for us to note that here. So we have base 1, base 2, and the height, we're told. Height is 18 feet. We're told that one base is a modified version of the other one. So let's call one of the bases x. It doesn't matter which one you call x. It won't mess up the problem either way. Where the other base is 19 less than 5 times that base. So 5x minus 19. And now we know the area, capital A, is 477. So now our job is to plug each of these things into the formula. So 477 equals 1/2 times, I'm going to need a bigger parenthesis than that, x plus 5x minus 19 times 18. So I'm going to go ahead and multiply 1/2 times 18 because I can multiply in any order. So I can multiply the first and the third things just fine and get 477 equals 9 times, and I'm going to combine like terms here, 6x minus 19. Now I'm going to go ahead and divide both sides by 9, or I could distribute the 9. And if I divide both sides by 9, I get 53 equals 6x minus 19. Adding 19 to both sides gives me 72 equals 6x. And dividing by 6 brings up x equals 12. So we're supposed to find the length of the longer base. So we found the base well, that one base is 12. So we know this is 12. But now we need to find the other base so we make sure that we know which one's longer. Hint, the other one will be longer in this case. So 5 times 12 minus 19. 5 times 12 minus 19. 5 times 12 is 60. And 60 minus 19 is 41. So the longer of the two bases is 41 feet. Once again, making sure we get the labels. Moving on to number 7. The measure of one angle is 6 more than half the measure of another angle. If the angles are complementary, find both measures. So even though the second sentence doesn't look like it has any math in it, it really does. Complementary means the two angles add up to 90 degrees, going back to geometry there. So we need to figure out the first angle and the second angle. So I'm going to put angle 1, angle 2, what they are. So let's call one of the angles x, and the other angle is a modified version. 6 more than half of it. So 1/2 x plus 6, or x over 2 plus 6. And now adding those up is supposed to get us 90. So we're going to say x plus 1/2 x plus 6 equals 90. As we talked about before, we need common denominators here to get those x's combined. X is secretly 1x over 1. So if we multiply the top and bottom by 2, we get 2x over 2. So that gives us 3 over 2x when we combine them, plus 6 equals 90. Subtracting 6 gives us 3 over 2x equals 84. And now I have to multiply by the reciprocal 2/3. So we end up getting x equals, and put 84 over 1, look to reduce, which we can, and we end up getting 3 to be 1, 84 to become 28, and so 28 times 2 is 56. So one angle is 56 degrees. The other angle we could find by plugging back into here, or saying we know they add up to 90, so we could do 90 minus 56, giving us 34. And so we have 56 degrees and 34 degrees as our two answers. Kelly, Laura, and Tia sold boxes of cookies for a fundraiser. Kelly sold 15 boxes less than Laura. Tia sold twice as many boxes as Kelly. If they sold 83 boxes in total, how many boxes did each girl sell? So we have to do 3 separate things off to the side here. 1 for Kelly, 1 for Laura, and 1 for Tina. So Kelly sold 15 less than Laura. Tia sold twice as many as Kelly. So we have to call one of them X. I'm going to go ahead and call Laura X. And that way I can comparing Kelly to Laura. I'll just compare Tia to Kelly after that. Doesn't truly matter which one you call X. It could work out regardless. But I'm just doing that because my first equation is based on that. So 15 less than Laura is what Kelly sold. So X minus 15. Now Tia sold twice as many as Kelly. So I take X minus 15 and I multiply it by 2, giving me 2X minus 30. Now we're told that all 3 of these ladies in total sold 83 boxes, meaning we're doing X minus 15 plus X plus 2X minus 30 equals 83. So this is Kelly, Laura, and Tia. Combining like terms, x, x, and 2x gives us 4x. Negative 15 and negative 30 gives us negative 45. Adding 45 to both sides gives us 4x equals 128. Dividing both sides by 4 gives us 8x equals 32. So we know Laura sold 32, but we still have to find Kelly and Tia's number. Kelly sold 15 less than Laura did, which means that Leah sold 32, so Kelly sold 17. Tia sold twice as many as Kelly did, so we could plug this in here, 32 in there, or we can just double 17, saying that it is 34. And if we were to add up these three numbers, we would in fact get the 83 that they sold in total. So now I'm going to write down here that Kelly sold 17, Laura sold 32, and Tia sold 34. And these are all cookies to use my label. When you have a label, you want to use the label. And I just wrote it again down there rather than using this because this is a little bit more organized in the corner. Number 9, the measure of the vertex angle in an isosceles triangle is 6 less than 4 times the measure of a base angle. Find the measure of the vertex angle. So even though this is all in one sentence, because we're dealing with an isosceles triangle, that presents a unique setup. So an isosceles triangle, if you don't remember, is a triangle where two sides are congruent, and thus the base angles, the angles opposite those congruent sides, are also congruent. Now we also know all three angles add up to 180 degrees. So we're told the vertex angle is 6 less than 4 times the measure of a base angle. So we're going to call the base angle B angle X. And we're going to call the vertex angle 6 less than 4 times that. So 4x minus 6. Now these would both be base angles, so those are both x here in this scenario. It's important to note because as we add them up to 180, we'll have x plus 4x minus 6 equals 180. As we add x plus 4x, we get 6x minus 6 equals 180. Adding 6 to both sides gets 6x equals 186. Dividing both sides by 6 gives us x equals 31. Now, we're supposed to find the measure of the vertex angle. We just found the base angle. So plugging it back in will get us the vertex angle. So 4 times 31 minus 6. 4 times 31 would be 124. Subtract 6, and we end up getting 118 degrees. Number 10, the sum of 4 consecutive integers is 222. Find the integers. So integers are non-decimal non-fractions. They can be both positive or negative. And we're adding 4 consecutive ones, which means in a row, such as 5, 6, 7, 8, or 10, 11, 12, 13. And there's add up to 222. So the first integer, we're just going to call x. The second integer is the next number, so x plus 1. The third integer is the number after that, x plus 2. And the fourth integer is the number after that, or x plus 3. And we have to add all 4 of these up to get 222. So x plus 1 plus x plus 2 plus x plus 3. Maybe you want to put it in parentheses so you can differentiate the numbers apart from each other. That's a personal preference if you want to do that or not. Regardless, you would combine like terms here and get x plus x plus x plus x to get 4x. And 1 plus 2 plus 3 is 6. Subtracting 6 from both sides gets you 4x equals 216. Dividing both sides by 4, x equals 54. So if that's the first number, that means the next numbers are just the following ones: 55, 56, and 57. You could also just plug them back into here if you wanted to as well, which would yield the same exact results. And there's not labels here because we're just talking about the number themselves. Number 11, the sum of 3 consecutive odd integers is 93. So this time the fact that they're odd integers is key. So the first integer would be x. The second integer, we no longer just add 1, because if we notice here, when we added 1, we got an even one. Or an odd, we went even to odd, add another one, odd even, another one, even to odd. So to go from an odd to an odd, we had to add 2. And so it would be x plus 2. And so to go to, that should be third, not fourth, to go to the next term, we'd do x plus 4. We'd add another 2 on top of that. And so now adding these three together, x plus 2 plus x plus 4 will equal 93. And you might benefit again from putting those in parentheses so you can tell each one of those apart. That's up to you. Combining like terms gives us 3x plus 6 equals 93. Subtracting 6 from both sides gives us 3x equals 87. And dividing by 3 gives us x equals 29. So that's the smallest of the three. So the numbers are 29, add 2, 31, add 2 more, 33. And if you wanted to check, those would add up to 93. Our last problem. Find 3 consecutive even integers such that the sum of the smallest integer and twice the median integer is 20 more than the largest integer. So we know that the first integer, we can just call x again. The second integer, we can call x plus 2. And the third integer, we can call x plus 4. Because just like you have to add 2 to get from an odd to an odd, you have to add 2 to get from an even to another even. Now, our equation instead, we'll be taking the sum of the smallest and twice the median, or middle one, so x plus 2 times the middle one, x plus 2, and saying it is, or equals, 20 more than the largest, so 20 plus x plus 4, a unique setup. So I'm going to go ahead and distribute the 2 here and get x plus 2x plus 4 equals 24 plus x. I'm going to rewrite that 24. Combining like terms on my left side gives us 3x plus 4 equals 24 plus x. Subtracting x from each side gives us 2x, and subtracting 4 from each side gives us 20. Dividing by 2 on each side gives us x equals 10. Now we're supposed to find all 3 integers, so since the first one's 10, the next one must be 12, and the next one must be 14. And 10 plus 2 times 12 is, in fact,